Hi, my name is James McGinnis. I'm team lead of Texas Guadaloop. We're facilitating the next great revolution in land transportation by making the Hyperloop a reality. Let's say you have to get from Austin to Dallas with one of the current four modes of transportation. This is a good example because it's true of kind of any city, two cities that are 200 miles apart in the United States. And there's a lot of them. So boats may have brought us to the United States, but they're not going to help us get to Dallas. Railroads connected the Atlantic and the Pacific Ocean. Amazing, but currently about 7.5 hours with all the starting and stopping to get to Dallas. In the US, we love our cars. They democratize the entire notion of transportation. But still, we have to drive 3.5 hours to get to Dallas, and that's with no traffic. And with airplanes, we can hop from continent to continent in less than a day's time, but we have to show up an hour and a half early just for a 40-minute flight. Really makes no sense to me. So clearly there's something still missing here, because over the past 60 years, we've made no commercial advancements in how we move around people and goods. We still have to pack ourselves in these densely populated areas just so that we can live close enough to where we work. But by combining the convenience of a train with the speed of a plane, we can cut down travel time between Austin and Dallas to just 20 minutes. How would we do that? By levitating a pod inside of a partial vacuum tube on a thin slice of air, we can essentially eliminate drag from our system. This would allow us to travel at speeds of up to 750 miles an hour. If you think that sounds crazy, just think back to the early beginnings of any of these modes of transportation. Almost everyone doubted them, and no one could have expected how massively they'd alter the course of the future or how much wealth they were going to generate. We're a team of 30 graduate and undergraduate engineers teaming up with SpaceX to build the first ever working prototype. In 2015, Elon Musk announced an international competition for student teams to design and build a working pod to compete on a test track that SpaceX is currently building for August 2016. We're one of the few teams remaining in this competition, and we've cracked the code due to our innovative air-bearing design. There's two ways that teams are approaching this. One is through magnetic levitation, and one is through air bearings. Although Elon Musk himself has stated that maglev is cost prohibitive and not sustainable for a full-scale system. In fact, we've all known that since the 70s. So what amazes us is that the vast majority of teams entering this build phase are pursuing maglev design because it's a technology that's already proven to work. But air bearings have never been attempted at higher velocities before. And that's what really excites us, because we could be the first team to demonstrate that they actually work. And the bottom line is that the Hyperloop is never going to exist as a maglev system due to the costs involved. So how do air bearings work? You can imagine an air hockey table where air is being pumped out of the puck instead of the table. And those 6 red frames you see on the bottom of our pod are the frames holding our hockey pucks, or our air bearings, pumping highly pressurized air into the track to levitate the pod. Air is free and doesn't require a power supply. So that's part of what makes this such a cost-effective and power-efficient system. We've designed a half-scale pod using entirely off-the-shelf components for less than $30,000. But because we're attempting something that's never been done before, we designed a very simple system. In fact, one of SpaceX's biggest compliments of us are the number of fail-safes in our design. So when it comes down to it, the physics are there, and this isn't something that's going to crash on the track in August. Our greatest asset, though, is our actual team. We're 50% master's PhD students and 50% upper division undergraduates. So we've worked in labs before, we've worked in industry, we've worked on design and build teams like this before, so we really know what it takes to get a project of this scope done, which is why we designed a very buildable system. There's all sorts of fancy designs out there on paper, but we have a very short amount of time to get this done, so given our experience, we've designed something that's actually going to get built by August. We also have a great team of entrepreneurs behind us. We're working with Josh Barrett Capital Factory and Bob Metcalf through our Longhorn Startup Program, which you know. So as we transition from a sort of research group into a full-blown startup over the summer, we have the right team behind us to get that done. And then SpaceX, they have a couple of brilliant engineers over there. They've been vetting our design and giving us feedback since day one. I think most importantly, though, is airflow. This company was founded by the inventor of the air bearings, and out of all the designs they've seen in this competition, they chose us as their #1 team to sponsor. We're working hand in hand with them to design a custom tailored bearing just for this application to show that their technology works. So if you'd like to get involved with sponsoring us or partnering with us, please visit us at guadaloop.com. We're at our booth right here. This is a great time to get involved because Over the summer, we're going to demonstrate that this isn't just some idea of science fiction, but it's something that's actually going to become reality. Thank you.
So, great job, by the way, I love the name.